This time with the Unimat SL, I'll be disassembling the lathe and taking a look at what condition it's in. Welcome to Adventures with a Very Small Lathe. Last time I unpacked the lathe and talked a bit about my plans for it. It looks like it's been out of use for a bit, so the first step is to take it apart, check everything over, and see what needs to be cleaned and fixed up. Before I do anything else, I need to remove the big heavy steel base. There's a bolt at each of the four corners and they're torqued from the other side, so I'll need to turn it over. The base is probably intended to make the lathe more rigid. Increased rigidity is always good for any lathe, but in this case it was probably necessary because of the larger, heavier motor. The bolts are cross heads with flat slots, and I don't have a flat-ended crosshead screwdriver anything like this, but a regular flathead screwdriver seems to do the job. Once the lathe is detached, it's a huge amount lighter and easier to handle. I'll work out what needs doing to the custom lathe base later. The easiest looking thing to remove is the tailstock. This single screw is keeping it clamped to the bed rails, and removing it allows the whole assembly to cleanly lift away. The carriage is quite a bit more complicated, so let's see what I can do. This screw looks like it locks the cross slide, and loosening it will just allow the slide to move more easily, but not much else. I'll back up the cross slide so I can more clearly see the part of the saddle which rests on the bed rails. The screw at the back looks as though it's the only other one I can remove, but unfortunately that doesn't help to remove the carriage either. Unlike the tailstock, the carriage isn't split all the way across the bed rails, so it can't be as simply removed. The rails are completely enclosed by the saddle casting, so it looks like I'm blocked until I can remove the bed rails from the base casting. Removing the headstock looks like the next step. It's held in place by this single large screw, but access is blocked by the drive pulley. To remove the drive pulley, I'll need to remove this large nut, but the obvious place to grip is the chuck, which is threaded the same way, so is likely to unthread more easily. To get a grip, I need to use this hole in the spindle shaft. Removing the nut reveals that the drive pulley also acts as an end cap for the bearings, so the bearing is now exposed and loose. I'm planning to completely strip and clean the spindle bearings, but it still makes sense to be very careful about getting any dirt or contamination in there. The headstock screw is tight, probably as it's important for keeping the headstock rigid. With the screw removed, it's still hard to remove the headstock because this locator pin is in place. The locator pin is firm, and the head's small enough that I couldn't remove it with my fingers. The pin aligns the headstock with the axis parallel to the bedways, and removing it allows the headstock to be rotated to any angle. To make sure the bearings don't escape or get too contaminated, the pulley needs to go back onto the spindle. There doesn't seem to be a key locking the pulley to the spindle shaft, which suggests this lathe isn't really intended for high torque. This stud on the bottom of the headstock looks like it's used to lock the headstock in place. The stud fits into this round hole on the base, and the large locking screw fits into this hole at the end. The tapered end of the screw looks like it tightens against the lower edge here and pulls the headstock down firmly onto the base. It looks like there are two locking positions available, the second one much lower down the stud. It seems likely that the headstock can be installed in a higher position by fitting a spacer between it and the bed, then holding it down with the retaining screw in this second slot. The bed rails are now exposed and it should be possible to remove them. They're each held by two screws, one at each end, that screw into the base. The screws come loose pretty easily with an ordinary flathead screwdriver. Turning the screws until they're completely loose doesn't seem to have made it possible to lift the bed rails though, so it doesn't look like they're screwed into threaded holes in the base casting. If I turn it over I can see that there are nuts on the underside, but they're deep inside these voids in the casting and not accessible enough to reach with a spanner or wrench. They're loose enough to be held with a finger though, and the bolts come free very easily. Now the rails are free, but the whole assembly is still held in place by the lead screw. There's a gap at the end of the lead screw between it and the part of the bed which acts as a base for the headstock. It looks just big enough to allow the saddle to come free if I run it all the way down to the end. This turns out to be an illusion though. It looks like the lathe's designer didn't intend it to be possible for the saddle to run free of the lead screw while the assembly was in place, so I'll have to work out how to detach the lead screw at the tail end of the lathe here. This wheel seems to be holding the screw in place and seems to be locked into position with this nut. I've guessed they've been locked together for some time as I don't seem to be able to hold the wheel firmly enough to move the locking nut. The wheel itself is very difficult to grip this close to the bed casting and is aluminium, so will damage very easily if I try to grip it with a pair of pliers or other rough gripping tool. The wheel handle is thin and I don't want to risk using too much force on it. WD-40 turns out to help almost instantly. The wheel is threaded onto the screw shaft and now comes off easily. The whole rails assembly now slides free of the bed. The bed rails can now be removed, but the corrosion at the end causes some resistance. In hindsight, I should have been more cautious with scoring the bore in the saddle with the rough corroded surface of the bar, but a bit more WD-40 seemed like it would be enough to free the bed rail. This rail feels sticky as though the saddle through hole is gummed up with old grease. The locking screw is completely loose, but it still takes quite a lot of force to pull clear. The lead screw is left-handed, so has to be turned in the counterintuitive direction to remove it. It feels as though the lead screw is only engaged with the thread for a short length at this end of the hole through the saddle. This is the Unimat stock fixed height tool post, which requires shims to set the tool to the correct height on centre. I'm already planning in my head how to replace it with a quick change tool post so I can freely adjust the height. The next challenge is disassembling the cross slide. Thankfully I watched Paul's video over at the Knackler's workshop, so I know that the two cross slide rails are held by two retaining screws accessible from underneath. Before I found this out, I thought the rails were pressed into the casting, so I nearly tried tapping them out, which would have damaged the casting and the rails. Thanks Paul for the heads up. Tapping them free will require the saddle to be firmly held, and all I have available is this workmate, so it'll have to do. I don't have any punches or scrap stock to use as a punch in my toolkit here, so I improvise with this Allen key. This was a dumb idea, as I could easily damage either the rail or the casting very easily. This rail was surprisingly stiff, and I was very nervous about hitting it too hard. It did move very slightly with each tap, so I kept at it. The second rail moved much more easily, but both rails ran into the same issue. The hand wheel was in the way of them being removed entirely, so that needs to come off first. The wheel is locked to the lead screw in just the same way as the other feed, but seems even trickier to remove. I tried locking the slide to the rails to hold the wheel still, but the rails were already loose, so this did nothing useful at all. I eventually worked out that using the hole for the wheel handle to lock it against the casting gave me enough leverage to loosen the locking nut and free the wheel. The carriage locking screw is in the way of sliding the lead screw free, but even once the locking screw is removed, the rails limit the saddle travel and still hold it in place. It made sense to remove the lead screw to avoid scuffing it, but that turns out not to be possible in this direction. The thread isn't cut to full depth at this point at the end of the main screw, so that won't pass through the threaded hole. The hand wheel is out of the way, and the easy up of the two rails can now slide free by hand, but the other is still firm enough to require more tapping. It took quite a bit of tapping to make the full length. This piece of threaded rod made a much better punch than the Allen key, but still isn't something I'd recommend. As the casting is non-ferrous, I should have used a softer material like aluminium or brass to punch the rail through. It looks like there's some burr or mushrooming at the end of the rail, which means it's difficult to pass through the hole in the cross slide. This lead screw is also left-handed, but once I turn it the right way, it comes free easily in the opposite direction from the one I tried before. The last part to remove is the cross-slide locking screw. There's a lot of caked-on grime here to remove, but that can wait until later. Now let's take a look at the headstock. The lever on top isn't fixed in place and lifts out easily. The chuck is fitted to the spindle with a thread, but it's now tighter than the drive pulley nut, and turning the chuck just turns the whole spindle. Fortunately, I can use this through hole again, which makes it easier to make sure the chuck can be unscrewed without the pulley coming unscrewed instead. The spindle thread looks in great condition, so I need to make sure I keep it that way. Now the chuck's removed, the spindle end is narrow enough to be pulled all the way through the headstock casting, but something is limiting the travel to this fixed distance. It looks like this screw head here is a retaining screw which limits the travel and keeps the spindle in place. It's a simple slot head grub screw and comes clear easily. It takes some gentle force to push the spindle through the headstock, as it looks like it's been some time. The spindle is now free of the headstock, which is all I'm going to do with it for now. Disassembling the spindle will require a lot more care, and I'm going to deal with that separately. The final step for today is the milling and drilling post. This is the most badly corroded part by a long way. The headstock bracket is very simple to remove by loosening this single clamping screw, after which it slides off the shaft. Now let's do an inventory of everything I have after the main disassembly to make sure I can still remember what everything is. There's the main bed casting and the two bed slide rails. The headstock and the spindle. The chuck. The tailstock, its clamping plate and screw. The saddle, the cross slide, and the tool post. The two hand wheels for the feeds. The main lead screw and the cross slide lead screw. The parting tool that was fitted to the tool post. The 4 bolts used to hold down the bed rails. The spindle advancing handle and the headstock retaining screw. The pair of cross slide rails. The saddle locking screw. The headstock alignment pin and the cross slide locking screw. The cross slide handle locking nut and the 4 nuts for the bed rail bolts. Finally, the milling drilling post and its headstock mounting bracket. There are 3 important assemblies that I haven't even started disassembling yet. The tailstock assembly, the spindle and the chuck. All 3 will need to be stripped down carefully and kept clean to make sure they function properly. I don't want to start on them until I've removed the bulk of the dirt, and I want to give each of the full attention they deserve. Most of the lathe is pretty dirty, and the dirt could contain hard or abrasive swarf, so I want it well clear before I start to work on the delicate parts of the lathe. The next video will be about removing the worst of the dirt and grime and seeing what I can do about the corrosion. The parts are made of different materials and have different coatings, but critically the importance of surface condition to how the machine functions means that the approach I need to take to cleaning will vary from part to part. These slots in the casting under the headstock are crucial for ensuring the bed rails are correctly aligned, so they have to be clean, but it's just important not to use abrasives which might change the precise surface of the slots and ruin that alignment. The headstock bore also needs to be handled carefully as it controls the spindle alignment. Under the grime, the original paint is in good condition, so if possible I'd like to avoid any cleaning techniques that would damage it. The milling drilling post looks the worst due to the rust, but while it does look badly pitted, I think enough of the original surface is still there for it to work well. Suggestions on the best cleaning agents to use for the whole project and things to look out for are welcome in the comments. So far I'm really enjoying the well-engineered simplicity of this machine, and I hope the process is interesting for you too. Thanks for watching, take care, I love you all.